In this example, we're asked to find the point on the graph of the function f of x equals x squared that is closest to the point 2 comma 1/2. Now for an optimization problem, this is asking us to do what? It's asking us to find the closest or the minimum, or to minimize what? The distance between some point on this graph and this point. So minimize the distance. This is going to be a distance problem, so we need the distance formula. If you recall, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. A quick sketch of this shows the idea, what we're going for. I can plot the point, say 1, 1 on the function, right? You plug in 1, you get 1. So that's going to be a point here. And then we have a point out here at 2 comma 1/2. So say a point about there. Then we have effectively this line. We're trying to minimize this line. Alright, and that line is given to us by this distance formula. So how do we go ahead and do that? We're going to take note that we have all four of these input values, x1, x2, y1, y2. If I let the x1, y1 pair equal 2 comma 1/2 and x2, y2 equal my function values, well, what can I plug instead of this? Well, for the function, we have x as the input. What's the output? The output is x squared. So let's plug in these four values, and then we get the distance is equal to x minus 2 squared plus x squared minus 1/2 squared. That's our distance equation, so that answers part 1. Part 1, get a little ahead of myself here, of our answer. Now it makes note that the radicand is sufficient for finding the smallest critical value. If you recall, the radicand is the value underneath the square root. This is the radicand. And it says that's sufficient because if the radicand is the smallest value, then the square root of that would also be the smallest value. Okay, so what we can do, instead of taking the derivative of d of distance, we can take the derivative of just the radicand. And that's what we're going to go ahead and do. We're going to say r equals x minus 2 squared plus x squared minus 1/2 squared. Now why do we want to take the derivative? Well, we want to minimize the distance. So if we take the derivative and then find the minimum value, that is setting our derivative equal to 0, we'll find the minimum distance. So r prime in this case, it's going to be 2 times x minus 2 plus 2 times x squared minus 1/2 times 2x with the chain rule. From here we can go ahead and multiply things out, see if it cleans up at all. And we have 2x squared 2x, that's 4x cubed. And then 2 times 2 is 4 times 1/2 is 2, so minus 2x. Now what do we get from this? We get 4x cubed minus 4, or x cubed minus 1, which when set equal to 0, we find that x cubed minus 1 implies that x equals 1 is a 0 of this function. Okay, so let's make sure we answer the question. Find the point on the graph, so we need the full point. That's what x equals 1. So f of 1 equals 1 squared. F of 1 equals 1, so we're looking at the point 1 comma 1. And that's it.